Welcome to chapter 1, section 1.4. Okay, chapter 1 covers functions and limits. We are in section 1.4, the tangent and velocity problems. This is where calculus begins. Okay, the tangent problem. What is the tangent problem? Well, the word tangent is derived from the Latin word tangens, which means touching. Thus, a tangent to a curve is a line that touches the curve. In other words, a tangent line should have the same direction as the curve at the point of contact. What does that mean? Look, you have a curve here. The line T merely touches the curve. Okay, it doesn't cross it. It barely touches it. Okay. Now there are some misconception. Okay. So for a circle, which is this, Euclid's definition of tangent was a tangent is a line that intersects the circle once and only once, like here. Here is a line which touches the circle only once. Okay. But for more complicated curves, this definition is inadequate. For example, here is a curve and here are two lines. One is line L, which is blue in color, and the other is pink in color, line T. Notice line L touches my curve C only once, but it doesn't look like tangent to us. Whereas T is a tangent to the curve. Notice T is a tangent to the curve at point P, but T does not remain a tangent at this point. Okay, so tangent is not what we think of as a line which touches your curve only once. That is not necessarily the only way tangent is defined. In fact, that's incorrect, as you see. So what is a tangent? Let's go to the definition. It is a curve. Tangent to a curve is a line that touches the curve. It doesn't go through. Okay. In other words, tangent lines should have the same direction. Now that is an intuition we want to understand. Same direction as the curve at the point of contact. Okay, so this line has the same direction as the curve at this point. But notice this line does not have the same direction as that of the curve. Over here, the curve is increasing here, whereas the line is going down. So this line T is a tangent at point P to the curve C. So the point matters. All right. Now, we want to understand how to find equation of a tangent line to any curve at a given point. So if you remember from your earlier classes, equation of any line can be written down if you know the point and you know the coordinate. All right. So what is equation of a line? Equation of a line, there are several definitions. One is slope intercept form. What is the slope intercept form? Slope intercept form is when you have the slope to be some number m and y-intercept to be some number b, that is the point is 0b. Then the slope intercept form, so equation of the line in the slope intercept form is y equals mx plus b. All right, slope y-intercept, hence the name slope intercept form. Another form of writing an equation is called point slope form. So you are given a point AB and suppose the slope is m. Then equation of the line passing through point AB with slope m is y minus y coordinate equals slope times x minus x coordinate. Okay, y minus y coordinate equals slope times x minus x coordinate. This is called point slope. Why? Because you need to know the point, you need to know the slope. And the third form of writing equation of any line is what is called standard form. Standard form is get the x and y coordinates together. It's usually ax plus by equals c for some specific numbers a, b, c. Okay. Standard form is after you simplify all of this, or here get x and y on one side and pure number on the other side. That's all. And then there are the special cases. Equation of a vertical line is x equals some number. Okay, a being the x-intercept. Equation of a horizontal line, y equals some number, b being the y-intercept. Okay, so these are the various forms of equation. So why am I explaining all this to you? Well, you want to write equation of a tangent line to this curve at this point. In other words, you have been given a point. You need to find the slope, because if you know the point, all you need is slope. All right. So the whole point of calculus or understanding calculus begins with knowing the slope of your tangent line. All right. So I'll stop my video at this point because it's getting a bit too long, and we'll continue with this example. Okay. Until next video then.